Setup Wizard. The Toshiba P9 Setup Wizard makes it so easy to completely set up your drive in just a few simple steps. Let's give it a try. Once in the program menu, select Virtual Linear Pump submenu and press Enter. Selecting VLP Setup Wizard opens the first system description screen where the P9 will ask for the full load amps rating of the motor. This rating can be found on the motor's nameplate. This P9 pump demonstrator uses motors with a full load amps rating of 3.2 amps, which is entered here. The next thing we need to do is to tell the P9 what application type to control. For this demonstration, let's choose pressure. Other options include flow and level. The wizard then asks for the command source. This is where we want to control the system from. Today, we will choose EOI. EOI stands for Electronic Operator Interface, which refers to the P9 keypad. The command source can also be programmed for one of the analog inputs. The final piece of information asked for on this first screen is the low frequency limit. This would be used for pumps that have operating frequencies below which the pumps should not be operated. This is typically for a vertical style pump, which we are not using. Therefore, we will leave this value at the factory default of 15 Hz. After completing this screen, scroll to Next and press Enter. The P9 now brings us to the second screen where it asks to define the transducer if using one. The information should be on the transducer itself or on its datasheet. For this demonstration, a 4 to 20 milliamps transducer is used. Let's begin by entering the units the transducer measures. This is a pressure transducer, so we will choose PSI. Other unit options are GPM, SCFM, degrees F or C, inches of water column, and feet of water column. Now we need to input the type of analog signal this transducer produces. The options are 4 to 20 milliamps, 0 to 20 milliamps, 0 to 10 volts, or 0 to 5 volts. For this transducer, we will select 4 to 20 milliamps. The next thing we need to select is full scale, or the range of the transducer. This transducer has a 0 to 30 psi range, so let's rotate the encoder to indicate 30 psi. With this information now entered, select Next and press Enter. The following screen prompts us to set the system for normal flow. For the VLP setup, normal flow means avoiding deadheading the pump or causing cavitation. Then, ensuring the P9 is in hand mode, press the Run button. After allowing the pump to start and accelerate up to full speed, scroll to Next and press Enter. The screen displays the pump VLP maximum and to the right a number. This number corresponds to the pump's maximum flow and indicates the upper end of the operating band. Be sure to make note of this value. VLP maximum will not normally need to be adjusted, so let's scroll to Next and press Enter. Now the screen prompts us to set VLP minimum number. In order to modify this parameter, scroll to the number and press Enter to select it. Notice how the number becomes highlighted. By rotating the encoder counterclockwise, the number will begin to decrease and the pump will begin to slow down. We will continue to lower this number until one of three things happen. 1. The pump begins to stall or surge. 2. The system pressure falls well below the operating pressure of the system during normal operation. 3. The red LED display indicates an output frequency between 31 and 32 Hz. For this demonstration, the output frequency between 31 and 32 Hz will be the criterion first met. Once this occurs, press Enter. The VLP minimum number will indicate the pump's minimum flow and will be the lower limit of pump operation. Let's make note of this number as we did with the VLP maximum number. Now we'll scroll to the next option and press Enter. The next screen instructs the operator to press Stop and states that the setup is now complete. Once the pump comes to a complete stop, the Exit option becomes available. In order to save all of the data just entered, Exit must be selected. The last step to commission this pumping system is to simply enable the VLP process. To do this, we need to re-enter the program menu and the Virtual Linear Pump submenu. Under this submenu, select VLP settings. Notice how the first parameter, Virtual Linear Pump Mode Switch, is disabled. To enable VLP, select this parameter, scroll to Process Hold, and then press Enter. The other option, Direct Mode, should be used when operating without transducer feedback. Since this system uses a transducer, we select Process Hold. After this, press Escape until we are back to the main operating screen. Notice our set value is displaying in PSI and the current value is 0.0. Also notice the two monitored items. The first monitored item will be the analog input that the transducer is connected to. It will also display in PSI, which allows for direct comparison between set point pressure and feedback pressure. The second monitored item is the current VLP number the pump is running at. Using the encoder, we raise this set value to 15 PSI and press Run. The pump will start and accelerate until the process pressure is 15 PSI. If we open and close our throttle valve, simulating system transients, the drive will automatically adjust its output to maintain system pressure. If we adjust the set point, the drive will automatically adjust to maintain system pressure to the set point we programmed into the P9. As we simulate these transients, notice the VLP number on the second monitored item. This number will vary based upon the mass flow of the system. This is the fundamental difference between a PID control loop and VLP process control. VLP monitors and controls mass flow, whereas PID is simply speed control. Next, if we monitor the set point value and the feedback value, notice how closely they track one another. In addition, notice as the drive responds to transients, the VLP number will remain between the VLP maximum and minimum numbers noted during the setup wizard. Noting these observations will assist when setting up sleep and external device functionality.